All right, everybody, welcome to the notes on Chapter 11, Section 9. We're going to talk about normal distributions. This will hopefully be some reminder of some statistic stuff that you may or may not remember from the whirlwind that is May of Algebra 1. So let's take a look at what we got. First, right here, just some vocab. Discrete probability distribution. That has a finite number of possible events or values, so it's a definitive number. The binomial probability distribution you studied in the preceding lesson, we'll talk about that. The events for a continuous probability distribution can be any value in an interval of real numbers. If a data set is really large, the distribution of its discrete values approximates a continuous distribution. We'll talk more about this, and hopefully this will make more sense. Big picture, the normal distribution has data that vary randomly from the mean. The graph of a normal distribution is what is commonly referred to as a bell curve, or the normal curve. And we look at it like this. There's some words here that you may recognize, like deviation and then obviously mean. In a normal distribution, there's some key numbers. 68% of the data fall within one standard deviation. You also may remember one standard deviation being a z-score of 1 or -1. 95% of the data fall within two standard deviations of the mean. And again, that's either plus 2 or -2 as far as z-scores. And then 99.7% of the data fall within three standard deviations of the mean. And this is specifically in a normal distribution that takes place. Sorry. So that's only within the normal distribution that this phenomenon exists. But these numbers are locked in anything that has been normally distributed. So sometimes there are extraordinary factors that would otherwise, that affect the data. Okay, so a coin, for example, may be somehow weighted unevenly so that the heads tends to come up more frequently than the tails. When this kind of thing happens, data can be skewed. The skewed end is towards the tail. It's not towards the data. So if we look right here, positive is this direction. This is where the tail is. So it's skewed in that direction. This is normal. And then here, you can see the tail here is skewed on the negative side. So it's wherever it can be skewed one direction or the other. So analyzing data that's been normally distributed, let's take a look at this. So zoology problem here, the bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed. About the mean, which is 115 kilograms, approximately what percent of female brown bears weighs between 100 and 129? So 100 to 129, if we estimate and add the percents for the intervals, we get 23 plus 42 plus 23. And again, those numbers, just so we can see, quick reminder of page before, we're using information from here, okay? The concept of the bell curve, all right? So we look at 101 to 109 right here, that's at like 23%, okay? We look at 110 to 119, that's right here, that's up here at 42, and then this one again at 23. So about 88% of female brown bears weigh between 100 and 129 kilograms. So this whole big chunk is about 88%, okay? That's it. Not real complicated. Take a look at got it number one. What percent of female brown bears in problem 1 weigh less than 120? And then the standard deviation in the weights of female brown bears is about 10. Approximately what percent of female brown bears have weights that are within 1.5 standard deviations of the mean? Go ahead and try and get answers there to 1A and 1B, and then we'll chat about those. All right, you're back. Hopefully for 1A, you got about 71%. If yours is a little bit off, but close to that, it's because you may have, maybe this was 23 and you put 22. That's fine. And then here for part B, that would be 88%, okay, based on the graph that we're given. All right. When data is normally distributed, you can sketch the graph of the normal distribution using the fact that a normal curve has a symmetric bell shape. So we're gonna draw now. God help us. So normal curve, more zoology. These are European eels. So ironically, we're measuring the European eels in inches. Man, irony. So the mean body length and one positive and negative standard deviation is shown below. Sketch a normal curve showing the eel lengths at 1, 2, and 3 standard deviations from the mean. So this is what we get. We get the mean of 15.7, and then we have 18.5 and 12.9. These numbers are all coming from here, here, and here. We draw them each time. We see that the standard deviation is 2.8, so we just continue moving 2.8 each time in each direction for the deviations of -3, -2, -1, 1, 2, and 3. It's really that simple. There's not a whole lot to this. Um, I'm not a very good artist, but even I can sketch these. For a population of female European eels, the mean body length is 21.1 and the standard deviation is 4.7. I'm not going to draw this one here because my drawing would be god awful, but you're going to draw some kind of bell curve. See, that's awful. So that you can practice with what the standard deviation is and +1, +2, +3, -1, -2, -3 standard deviations away from the mean. All right, go ahead and do that. We'll go over that in class together when we look at the notes. Go ahead and do that now. All right, you got your drawing. Hopefully it's a thing of beauty. I'll tell you what, let me show you. I'll give you an example of what it could look like right now. Hold on. So there you go. There's a nice pretty drawing of what you should have, the standard deviations, the lengths, the frequency. That one's much prettier than anything I was about to draw. Analyzing a normal distribution for these problems, what percent, let's take a look, we have some basic information here. We have a mean of 69.5 and a standard deviation of 2.5, and we have the normal curve here. So what percent of adult American males are between 67 and 74.5? So that percentage is this 34, and that 13.5. So it's about 81.5 or 82%, really, that's simple. In a group of 2,000 adults, what would you expect to be taller than 6 feet? So we would expect half. If 6 feet, this is half right here from here to here. 72 inches would be here. So that's 6 feet. So we would take our 50%, we subtract our 34%, and we get about 16%. Pretty simple stuff here as far as, just doing some real basic math. Go ahead and pause the video here. See if you can get answers about scores on an Algebra 2 final exam. Their mean of 150, standard deviation of 15. Get some answers to A, B, and C. Go ahead and do that now. All right, you're back. Percentage of students who scored above 180, that was 2.5%. Here, if 250 students took the final, how many scored above 135? That was about 210 students. And then this question, if 13.6% of the students received a B, how can you describe their scores? We would say that the students that had received a B had scores between 165 and 180. That's how I would describe them numerically. All right, that's it for the video, guys. I will see you in class, and we'll talk about normal distribution. We're also going to talk about Z-scores when you get here. All right, see you next time. Bye.